unsaturated. What does that mean? Or let's start with saturated first. Then. How do you know if something is saturated? It's what? Okay, it is holding its mass. Okay, so the maximum amount of the solute is dissolved. Okay. Okay, the maximum amount of the solute is dissolved. If it's dissolved, what does it look like? Right? Right? So, what about if it's unsaturated? Okay, the more can be added, more what? More solute can be added. And how would that look in comparison to this picture? Really? How would it look in comparison to this picture? Hmm? It looks the same, right? You can't really tell. How can you tell the difference between these two? All right. If you add more, okay, go ahead and finish. If you add more, right. If you add more, so the only way to tell the difference between the two, if you add more and it wasn't saturated, it's still going to look like this, correct? Okay. But if you add more, so it was unsaturated. Okay. But if you add more and it settles to the bottom, then that means it was what? And this one was saturated. Not super saturated. Now I'm going to tell you why. Okay? For you to be super saturated, so this is the one that was kind of tricky. Okay? For you to be super saturated, that means you have more dissolved than you're supposed to. It still has to be dissolved. Okay? So it has to be more dissolved than it should be able to hold. Okay? So how did you get it to hold more than it could anyway? You have to heat it up. Okay? More dissolved than it should be able to hold. Right. So the difference is, okay, let's think about solubility curves, right? If I take this solution right here, okay, that was saturated, but had stuff on the bottom, and I heat it up, then I can dissolve that stuff, right? But technically, if it's still warm, it's still saturated. Why? What happens as you heat up stuff? What happens to solubility as you increase heat? If you're increasing the heat, the solubility should increase, right? Now, if I take that same thing that I heated up and got it to dissolve, okay, so now I went from this to this, but if I drop the temperature back down, then it's supersaturated. Does that make sense? Because now it's holding more than it should be able to hold, let's just say at room temperature. Okay? Now, if I add another crystal into it, what happened when we added the second crystal yesterday, or the second time we added the crystal? Everything fell back out. All this stuff that wasn't supposed to be there came back out. It was just a lot. Okay? So at that point, when it fell back out, is it super saturated, or does it look like this again? So now it's saturated again. Does that make a little bit more sense? Be honest if it doesn't. Supersaturated means it's holding more than it can hold at a specific temperature. Okay? So think about this. Let's look at this curve, right? All right, so we had some curves here. Let's just say we had the, let's say we had the sodium nitrate, right? let's say yesterday we were working with sodium nitrate. And let's say the temperature was 30 degrees and you put 95 grams in there. Well, fine, that's how much it needs to be saturated, right? Now, if I add anything else in there over the 95 grams, it would have settled to the bottom, right? So let's just say I added in 110 grams. Okay? That extra 15 grams will be at the bottom. But if I heat it up at least to 50 degrees, well, let's see, at least to 50 degrees, then that stuff is saturated, right? Because it's still on the line. It's either saturated or unsaturated. But once I cool it back down, then it's holding more than it should. I feel like I'm helping you guys through this. So, in other words, on here, this one would not be super saturated until it was at a temperature where it wasn't supposed to be able to hold that much. Okay? Because if you just heat it up, well, at the heated temperature, it should be able to hold that much. So it just feels saturated.
I got you.
Alright, anybody want me to explain it further?